All right, so now that I have some nice white space, I'm gonna do this drawing in 3 parts, I think. I'm starting with my diaphragm, which is the lower limit of the thoracic cavity. And then I'm gonna be pretty lazy about drawing the rest of it as far as like body stuff. So just to orient you, I will switch over and I will draw a little outline of a person. I put their neck way over there for some reason. That was silly of me. Okay, so we're obviously in the chest. So we've got lungs, and you can see that this one's the left one because of the cardiac notch or cardiac impression, which means that oops, smaller dot, please. So let's zoom in on this. The heart is covered. And so I'm going to build from the heart out. So I'm going to draw my little heart as being red, and then I'm going to draw the other stuff on top of it. So let's see. I don't know that I've ever drawn an anatomically, correct heart on this program before. So let's see how I do, I guess. There's the right auricle. Superior vena cava. Got pulmonary trunk. I made that too long. There. Roughly like that. Okay, so that's just the bare heart. Myocardium is facing nothing. If the heart sat like that in the chest cavity, it would be extremely vulnerable to infection. So we can't have our precious, precious myocardium facing anything and standing the risk of becoming infected with stuff, which means that we have to line it. So directly covering the surface of the heart is a layer called the visceral pericardium. And that means that it covers the surface directly. And then it folds over at the top. And then we have a layer that lines the mediastinum itself, and that is the parietal. So you'll notice I still haven't gotten to the pericardial cavity yet. I will momentarily. But I want to do one thing first. Move this. So both the visceral pericardium and the parietal pericardium are serous membranes, meaning that they are a kind of mesothelium that produces serous fluid. There is another aspect of the pericardium, which is on the very, very outside, and it's continuous with and stuck to the parietal pericardium. And that is this guy. And there's no space between these two. I'm trying really hard to draw the lines right on top of each other so it doesn't give the impression that there's a space. So the fibrous pericardium, as you might expect, is made out of collagen, and it has a structural function. So you don't want your heart banging around in your thorax, bumping into stuff as it contracts, especially if it's not beating, or excuse me, especially if it's beating very hard, like, you know, you're exercising or whatever. So the fibrous pericardium not only covers the outside of the parietal pericardium, but it also helps anchor the apex of the heart, which is the pointiest part, helps anchor it to the diaphragm. So where is this pesky pericardial cavity? It is the space between the visceral and parietal pericardium. Now, in anatomy, we call this a potential space. Which sounds confusing. Here's the deal. If we know that these guys are both serous membranes, and they are, that means that they look like this. Let's zoom in here. So I have myocardium in red, and then I'm turning my laptop so I can draw this. So these are squamous endothelial cells. And then underneath that, there's a very, very thin, fine layer of loose connective tissue and fat. So if you need a review on serous membranes, go back to chapter 1 and chapter 4. So if you were to zoom in on the parietal and visceral pericardium, they look like that. So let's draw the parietal one. More squamous cells. Let's give them nuclei. And all mesothelium has to have a loose CT layer. Okay, so now we're getting to the crux of the matter. So this little space between these two layers of squamous cells is the pericardial cavity. The reason we call it a potential space is because both of these two layers, the visceral and parietal serous pericardium, secrete a transudate that is a thin, watery fluid. And what color do I want to make my thin, watery fluid? I've run out of blues, so why don't we do gray? I'm avoiding making it green because that implies an infection and I don't want to do that. So they're not connected to each other, which means they can slide smoothly past each other. But there's also not a physical gap in this space in a healthy living person, and there's not supposed to be. So the pericardial cavity should be 2 layers of squamous cells almost touching, and then separating them is some fluid, and that basically serves heart. So as it beats, it's not generating friction with its surroundings. And that helps to ensure that it's not damaged by its own action. So that is what I mean by a potential space. Now, what that means is you don't want stuff in there that's not supposed to be in there. So air, fluid, blood, and disgustingly, pus are all things that sometimes get in there in some people due to illness or injury. And these impair the ability of the heart to fill up with blood, which reduces its efficiency. So the outcome of that, can I move this please? Thank you. So that equals in a decrease in, let's draw that differently so people don't think I mean pointing down at, a decrease in cardiac output. So that explains those spaces. Now, just real quick, this schematic that I've shown you about the relationship of the parietal and visceral layers with this thin fluid between them, we've got the same thing over in the lungs. It's just that we call those the pleural lining. So the visceral and parietal pleura instead of pericardium, because they're associated with the lungs and not the heart. Oops. So let's take a quick screen of that before I stop recording. And goodbye.